We are on to our last topic in 5.5, and this topic is solving trig equations, where when we do isolate that trig function, we wind up not being able to use the unit circle. For instance, you are not used to seeing the x value on your unit circle of -4/7. So in other words, you can't tell me what angle that is off of the top of your head. Okay. So what we're going to do here is we'll go ahead and just start off by using cosine inverse. So we'll take cosine inverse of each side. So that looks like x equals cosine inverse of -4/7. And note, we're being asked to write these solutions down that occur in the interval from 0 to 2 pi. And 0 to 2 pi, that is an interval that's being described in radians. So make sure when you go to plug this in your calculator that you have your calculator in radians. And if we round this to the 4th decimal place, we get 2.1790. Okay. Now it ends up that on this interval, there's actually one more solution. And you can check this graphically. You can look and see that cosine of x is equal to -4/7 more than once on that interval. Okay. But let's think about this in terms of our unit circle. We're going to make a little sketch here. Now that we have our unit circle sketched, let's think about where this angle that we found actually lies. And I'm actually going to call it maybe x1 because we're going to end up with another answer here. So if we were to think about where this lies, well, cosine of x is negative in quadrants 2 and 3, right? But if we use cosine inverse can only give us angles that lie in quadrants 1 and 2. So the only overlap here is quadrant 2. Okay. So we know that our angle lies in quadrant 2. I'm going to sketch it. Okay. So here is our angle x1, okay, in the second quadrant. And now what we want to think about is on the unit circle, where would be a spot on the unit circle where we have the same x value? Okay. And so in order to find that, you would just work your way straight down the unit circle. Okay. And so this angle here and maybe I'll make it a slightly different color here. There we go. This angle right here would be another angle that would result in cosine being -4/7. This is what we'll call x2. Okay. In order to find the second answer, could be a little bit tricky. You might note to yourself, well, hey, I know it's pi radians to get to here. Okay. So that's one thing. And if maybe we could figure out what this angle here is, we could do pi plus that to get our answer. So I'm going to just write in here pi plus this little angle here that we'd like to find in between the x-axis and the terminal side of x2. Okay. Well, let me hit back there real quick. So if we do want to find that angle, we could instead start off by finding this one, because it should be the same. Okay. So if we're trying to find this angle here, we could actually do pi minus x1. Right, pi minus x1. If you take away x1 from pi's, what you'll be left with is this right here. This angle here. And that angle there is the same as this one here. Okay, this is symmetric. Okay. And so if we were to go ahead and add these together, then we have pi plus pi minus x1. This should come out to approximately 4.1041. Now, you might be hoping there is an easier way to do this, and there is. Let's see what that is. We're going to go to our graphing calculators right now. So let's see if we can find x1. Okay. That should be this first intersection right here, right? Because it was a smaller angle. It was 2 point something. Okay. So to find that one, we're going to hit second and then trace. And then we'll go down. Oop, I went down a little too far. Down to intersect and hit enter. And now the calculator can have a bunch of different functions graphed at once, not just two. So is what our calculator is asking us is what's the first curve? Okay? And this is asking us this because, again, there could be more than one curve in here, or more than two, I mean. Okay? So if we go ahead and hit enter, saying that, hey, that is one of the curves we're concerned with, the cursor will now blink on another curve. And if that's the other one we're concerned with, we hit enter. And then the only other thing we have to do is move the cursor towards the intersection here, and we just hit enter. And so we have the intersection. And if we were to round this to the fourth decimal place, we get 2.1790, which is exactly what we had gotten for x1. And if we want to try this for x2, then all we need to do is the same thing. Second, trace. And we could go down to intersect, hit enter. And then if I move my cursor over, you can see I'm on one of the curves. So I'll go ahead and hit first curve. I'm on the other one now, second curve, so I'll hit enter. And I'm just going to move my cursor now towards or closer to the other solution, okay, over here. Okay. And it actually doesn't have to be so exact. I could be, as long as I'm closer, it should be fine. And so I'm closer here to the solution I'm looking for. And if I hit enter, it gives us our other one, 4.1041. And so that was hopefully a lot easier than what we tried when we first tried this example. We are on to our last example here. And I would actually like you to try this one on your calculator before I type it in on mine. Okay. And so I'm going to go ahead right now and switch to my TI-84. And we are going to type this in and get our solutions from the calculator. Now that we have our calculators open, let's type in the equation, or at least one of the sides. So we had 7, and then we have sine of x, right? Sine of x squared minus 1. And if you want to, you can technically type in y2 equals 0 here and then find that intersection. But there is actually also a button that can find roots, which is really just finding when the graph crosses the x-axis, which is what we're looking for. The graph crosses the x-axis when y is 0. Okay. So let's go ahead and look at our window for a second. Remember, we have 0 to 2 pi on here, which is perfect. Our y values are large enough that we can see the intersection. And so we didn't have to make y min or the y max very big here because the intersection's happening along the x-axis. So let's hit graph. And you can see now on the interval from 0 to 2 pi, we have 1, 2, 3, 4 answers. And if we go ahead and hit second calc, instead of using intersect, we can actually use 0 here, since this one was equal to 0. So if I hit enter, and it's going to ask me pretty much the same questions, or similar questions. So this says left bound, so this just means we want to go to the left of one of these roots. Let's make it the first one. So I'm going to move this over quite a ways. There it is. So I want it to be left of the very first root here. So I'm to the left there now. I'm going to hit enter. I'm going to go to the right of the other one, or the right of this root, and hit enter. And then I'll just move this cursor in between those two and hit enter. And we have our first solution. And if we round this to the fourth decimal place, we get 0.3876. So go ahead, find the other three. We're going to go ahead and jump back to OneNote, and we'll write down what these 4 solutions are. Now that we're back in OneNote, let's write those solutions down. The one that we found here together was x is equal to 0.3876. And then if you went and found the other 3, you might have found another solution is 2.7540. And another one would be 3.5292. And the very last one on the interval from 0 to 2 pi would be 5.8956.